Okay, thank you. I'm really excited to be here. Like you guys all know, this is my first talk, so yay. Okay, first of all, I'm Zainab Lawal, as written on the screen. I will be talking about the AI's toolbox, solving the system challenges of a multi-tool data agent. Okay, so first, let me quickly introduce myself. Who am I? I am currently an applied AI engineer at Decide. I work on orchestration, evaluation, and just making sure everything works like it should. On the side, I'm studying, like, I'm pursuing a master's degree in artificial intelligence. I'm currently doing some research on breast cancer. So, interesting stuff. What should I be talking about today? I would be talking about the dream versus reality. What did we want to build at the side? Where are we? Like the problems we ran into that made us realize, like, oh, we're actually building a real product with real problems. I'm also going to briefly talk about our engineering journey from like the brittle networks we started with robust to robust orchestration. Also, the studio shift. This is about like tool communication and all of that, security and flexibility, resilience. This is actually, I think, my favorite part of the talk. So I would advise you guys to stay for that. And also the road ahead, what we plan to do as we continue. So I would start with this quote: complexity kills, it sucks the life out of developers, it makes products difficult to plan, build, and test. This was said by Ray Ozzie, a former chief software architect at Microsoft. So this actually is something that is always like at the forefront of my mind whenever I want to work on any project, because I also do a lot of research. You know, you always have to start with the MVP, right? You start with first thing you want to show your users, the important thing. We say an AI data agent. What should it do? You should be able to upload some files, maybe CSV, Excel, whatever, and be able to get some insights from it, right? So this was our dream, like you can see. So we just wanted to build a simple, powerful tool. Ask a question in plain English. The AI should be able to understand, connect to your data source, wherever this is. It can be like from a website, your database, Metabase, whatever, and return an accurate, insightful answer. But the problem, like we eventually figured out, is like LLMs. I might be using the term LLMs and AI agents interchangeably, but I guess you guys would understand. So we realized like LLMs are like a very good brain, but the problem is they don't really have the hands to carry out some tasks. Okay, it can understand the data. Like for example, ChatGPT, write a prompt, it understands, but at the start, it couldn't really carry out other tasks like, you know, fetch something from the internet, do all of that. So we had to add these extra tools to it. So, messy reality, the problem with solving data-based problems. The first challenge is the disconnected data landscape, and the second is the unpredictable AI brain. So, let me explain in detail. First, disconnected data landscape. We sometimes work in a particular field where we have different data sources. For example, you have your main database, Postgres, hosted somewhere. You have some Excel files you want to also do some search on. You have some CSV files somewhere. You know, there's so many things everywhere. For example, I want to ask, what's the best selling product on Amazon, maybe. So I want to check my database because like real time, but I also want to check, like, let's say I have some Excel file, compare and do all of that. So we want to do all of that fast. A monolithic AI agent can't really do that because there are so many things you need to check. You also need to pull web data. You know, it's a lot. Next problem is the unpredictable AI brain. This is actually where most of my work comes in. So unlike traditional products where you have like, let's say a traditional API, the user inputs something. Let's say it's an endpoint that accepts a message, stores it in the database and returns true or false. You know it's going to accept a message. You can do like validation based on the inputs. It should be text, it should be this length, it should be all of that. It's easy to kind of make secure and safe. Then the endpoint itself, it either returns true or false. True if it's stored properly in the database, right? And false if it's not. Easy. But the problem with AI agents that accept natural language is when we say fuzzy inputs, the user can request anything, they can write anything in any language. So you need to be able to build something that is robust that can capture all of this because any ambiguity can lead the tool on the wrong path. For example, I say, I want to see the let me see. Okay, what color of shoe is best selling in our product? Like in our product catalog? Yes, it seems like a simple prompt, but okay, what if I have like shoe products? What if we have like clothing? What if they are all separated in different databases? So, you kind of have to be specific, but you also don't want it to be too specific because at the point, sometimes the user is like, instead of typing all of this, I can just perform the search myself. So you have to sell value, but in a very unambiguous way, if you guys get what I mean. Also, we have non-deterministic outputs. Unlike a traditional LLM, like API, like I said earlier, the output isn't something you can easily predict and validate. If you remember my previous example, I said it can either return true or false. But here, it could be anything because let's assume you are working on like, let's say, okay, you are calling the Gemini API. Today, it's updated. Tomorrow, they can do some tests. And what exactly you've kind of worked and tested on can change at any time in. So these are like some kind of unique challenges that make every interaction a breaking point. The inputs might be faulty, the output might be faulty, the LLM might be faulty. So what works today might break tomorrow. And also we have security risk. This is about code generation because when you want to perform some kind of analysis on data, like my Python friends will know this, you have to run like Panda something, import this to that. There's so much you have to run. It's like data analysis is a whole job anyway. So how do we trust our AI generated code? Where do you run it? Like, is it going to run it well? How do you run it securely? You don't want to expose your system, but you also don't want to over restrict what the tool can do because, like I said, everything is about performing best value for the users. Also, we have hallucination and errors. This kind of ties into all of this because when your input isn't clear, where the output can change, and also when you want to like, okay, we don't want this agent to be able to delete files. So okay, it tells you, oh, I've deleted the file, but it actually hasn't. So it can misunderstand, make illogical leaps, or generate incorrect code or query. So I would kind of take you guys on a quick walk of our technical reality. So first, I should make a disclaimer. At Decide, my work is a bit abstracted from the original team. I kind of do all of this orchestration research, which is then implemented. So all of this is my pre-research before the actual product. So first, our first architecture, networked microservices, we thought, okay, simple, right? Just have like a fast API app, call this microservice, call this code. I mean, it works. It's decoupled components, familiar pattern. It's easy to set up, it goes fast. Do anything, just send it over, send like the request over HTTP, and it works. But why did this fail? Deployment complexity. Like first, now you have to think like, okay, is this server running? Is this server running? There are like so many things to, like also we have like versioning problem. This is actually a problem that is really particular to Python. Let's say the agent wants to use a particular, what's it called, a particular package, but it's dependent on another old package. And how do you migrate all of everything, but making sure it's consistent? It's a bit tricky. Also, we have like fragile connections, port conflicts. If one tool doesn't send a request on time, everything breaks. How do you debug it while keeping like privacy? Because we shouldn't have access to the user files and stuff they upload. So we realized, okay, it doesn't really match like the reality of what we're trying to build. So let's go to our next stuff. So now we come to like standardizing AI tool communication. I don't know if you guys attended. There was a previous talk about building AI agents in Elixir. It was really good. It's kind of like a precursor to this talk. So we brought up MCPs. They were introduced by Anthropic, I think, the cloud guys. So we say, okay, we don't want to make like so many custom HTTP servers for everything. Why can't we just plug and play? This is where MCP comes in. It's like a way to standardize every, I would say, tool for this context. It's a way to standardize everything you're doing. You need to make a database query or something like that. There's a standard tool. The output is the same for everything. So it's easy to debug. Everything kind of look the same. It's like a ports where you can just plug in something and get the results. So everything speaks the same language. And it's like a hardened interface because the AI never gets the credentials. Because before, when you have the HTTP connection, first you have to like, okay, database URL, blah, blah, blah. But now with MCP, it's like a little layer of abstraction. You don't have to give the AI stuff to make like dangerous action. So what does it stop? In terms of hallucination, let's say the AI accidentally hallucinates something, delete from users, blah, blah, blah. It can wipe your whole database. So with MCP, for example, the Postgres MCP, we use the principle of least privilege. This means like you only give it what it needs to perform its tool, no need for like extra permissions and all of that. So for our Postgres MCP, we only give it like select statements. It can query, do all of that, but it doesn't need to delete, update, or all of that, which I think is pretty safe. So let's go to the next slide. Now we have the MCP architecture. We have like our client and server because that's how it works. So our client can be understood as our orchestrator, like our main app. First, it gets the user's inputs, like breaks down the task into like little tasks, then it sends the request to the MCP server. For example, I want to, let me go to the previous slide, sorry. Query this table and tell me like what's the first user we ever had and decide, I don't know. So the MCP client understands this input, breaks it down into a task, and then it sends the request to the server. I don't think you guys can see my arrow, but yeah, it sends a request to the server. So the server is the tool that performs this action, the query, blah, blah, blah. It connects to Postgres, passes the file, does all of that, and sends the response back to the client. So it's like abstraction, but it works fast. Really nice tool, I recommend. Now we come into communication. So previously I talked about using like HTTP, sending everything over HTTP. It's kind of slow, it can break, packet loss, and all of that. So instead we switched to Studio. This is like, try to imagine this as a pipe between different processes. So first, the way it works is we spin up our MCP client, our orchestrator, which is like the main app. It's a process, imagine like that. Then we have these MCP servers as sub-processes, like child processes. So that way, when we want to pass data to the server, from the server to the client, there's no need to like send it over because it's a child process. You just like pipe the outputs into the client and same way you pipe the inputs to the server. So it's like no, what's it called? No throttling, it's fast and sorry, what's that? It's reliable, yes, because there are no, it's like, sorry, yes, like it's reliable because there's no overhead, yeah, network overhead. So if we look at this, you can see this host with MCP clients. You can imagine that's your app. And then we have the MCP servers, which connect to the other data sources. So if anything happens, you want to extend the app, you want to add another feature. Let me say we wanted to add Google Analytics. So you just have like the MCP server for that. You connect it to the MCP client, which is our orchestrator. Studio in, studio out, all of that. Everything is kind of abstracted. In a way, it's kind of like front end and back end for AI agents, if you think about it, because like the client is what interacts with the user, the server is everything. And what I love about MCP and all is like each, these days, most companies and stuff, they come up with their own standard MCP servers. Like that way, it's something you can just easily implement for yourself. So I think this current solution is lightweight, it's fast and reliable. So now we have MCPs, right? And we are able to have our orchestrator. So this works when you start up the app, we have the different tools you want to use. Then when the user says like, okay, fetch me this from that, the orchestrator is able to break it down into different tasks and ready to go, right? Now, the main problem, security challenges. How do you run LLM code? Actually, should we run LLM code? That was actually a main topic. First of all, to do analysis, we do have to run code. But what if the code tries to access system files? What if it tries to make like malicious network calls, dependency injection, errors, crashes, resource exhaustion? There's just like so much to consider when you start running code. So we decided like we needed a way to execute the code, but independent of our own system. Like we do not want to compromise the security and stability of our system. So this was when sandboxes came into the story. So sandbox is like an isolated environment you can use to run AI generated code. There are different, how do I say, there are different providers. We have like Daytona, E2B. I think Cloudflare recently launched like a sandbox feature. I wasn't able to try it out yet, but Daytona is really good. I like it. So why do we use sandboxes? First, isolation. You are able to run this generated code in a completely separate environment from your actual what's it called, your actual system. Think of it like this: the user makes a request, we spin up a sandbox, and we're able to upload the file into the sandbox, run everything. When it's done, you can easily shut it down. If there's an error or something, you shut it down. There's no compromise. You know, it's like giving the AI agent a computer to work on its own. It's really cool, really nice. Also, we have resource limits. You can set up the limits to avoid like infinite loops, like what's it called? Depending on what kind of code they run, maybe it's something that doesn't perform like garbage collection, stuff like that. So resource limits, you can easily set that like, oh, when it's exceeding blah, 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 shut it down because it shouldn't do that. Also, we have like a clean slate because for every session, we want to have like a different environment. So for each user session, or we can say like chat, like chat GPT or something, you know, when like, oh, what is blah, 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 we do not want it to interact with the previous stuff. So sandboxes are really good. Process isolation, no system access, like the AI agent doesn't have any access to our system, no cross-contamination. Like let's say a particular prompt causes the agent to create some malicious code, it doesn't affect the rest of the users or the rest of the chats in the session. So, okay. Now that our AI agent has its own computer, what else could we do with this? This was actually a very interesting question. So your AI agent has a computer. It can do anything. It can install anything. It can like think of it as like opening its possibilities. Like wow, anything literally. I don't know if you guys use Gemini. That's like my example code execution. Currently, it has some like limited packages. I think it's limited to like pandas, TQDM, the basic stuff. But now, when you plug in your sandbox, you can easily install things. Maybe I want to train a model. You can be like, oh, okay, and then it installs what's it called, TensorFlow, blah blah blah, in the sandbox. If anything goes wrong, it can easily be shut down. So unrestricted library access is a good benefit of sandboxing. The AI can dynamically generate any code it needs, runs it in the sandbox, and kills it whenever it feels like. And it also allows us to extend like the kind of data we can work with. I think when we started with CSV files. Simple. Just use like pandas and all that. Then eventually we started speaking with users. Some people wanted to run like Excel files, SPSS for statistical analysis. So we can easily, the AI agent, not us. So the AI agent can easily like, okay, it needs to run this code, this is missing, pip install this or that, and plug it in and get the job done. So also, before I continue, there was a question somebody asked in the earlier talk or previous talk, like how do we prevent what's it called, agents from running rogue, malicious code and hallucinating? This is actually what we do at this side, like sandboxing, and yes, it works. So my next topic is resilience. Am I going a bit too fast? I feel like it's fast, but okay. So the self-correction loop. Sorry, one second. Okay. So the self-correction loop, what if our agent hallucinates? What if it's like runs into an error? When, okay, let's say somebody asks like, okay, um, give me an example. Somebody, what if our agent, somebody imputes like, okay, what is the top director in this CSV file, but the CSV file is not related. Normally, the AI would generate like some code to analyze, you know, the column director. But if it's not in the file, it's just going to return like an error or something. So with resilience, our self-correction loop, we're able to make the AI learn from its own mistake. This is like reinforcement learning in real time, except like a lightweight version. So what happens is like first the AI generates its code, it runs it in the sandbox. If there's no error, return the results back to the orchestrator. Like simple, it's good, right? But if it's wrong, we pass in this like failed result, the failed code, we pass in the prompt and the what's it called, the file back to the LLM, and it's able to like reevaluate, okay, why did this go wrong? Why did this happen? Blah, blah, blah. And it's able to retry the execution of the code. But obviously we put like limits on like how many times it should retry and all of that. So this is actually a very nice way where we're able to improve on our code. Because for example, let's say it runs into an error the first time and you do all of this, okay, it learns from the mistake. And the next time it has a similar prompt, it's able to know like, okay, this is blast, this is this, you know, corrects itself. Like it grounds its reasoning in the reality of this execution environment. But you also remember like this environment, it's a sandbox, right? So this means like this self-correction is only limited to that chat. Because sometimes you want to do something this way, but just for now, just for like this project. So this also is isolated and self-contained. So, foundation for the future. What are we going to be building? I don't know if you guys follow me on Twitter, but I was once talking about how we're probably going to start building like on-premise stuff. Like, so how do we connect services that work locally? Let me give like an actual examples, right? Let's say I have an app running on my computer. I am not allowed to send data out of my physical computer. So how do we now analyze data from that data source? So what we plan to do, or what we've been considering, is like the butler architecture, where we have like a lightweight agent on the physical computer where you can just install from the app store something which like performs the analysis and blah blah blah. Then everything stays on premise, like on the physical computer, but we are able to like generate the code and all of that on the side, like on our servers. So this is an interesting challenge that we would be looking into in the future. But yeah, conclusion, this is kind of short. But first, orchestration is key. Like an LLM is a powerful brain. It can do so many things. But you just need to know how to help it connect with other tools. Like it's not enough to think. It's the same way we say like, okay, school smarts and all of that. Like how do you apply this knowledge? How do you apply this school smarts in the real world? Second, architecture built for the future. Why I like MCPs is because, like I said earlier, it's plug and play. This MCP added, it's like you want to build something else. Like I said, we want to extend Google Analytics. All you have to do is just like tools, blah, 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 add the existing MCP. So while you are building an MVP, I think it's also good to have a good architecture from the start, or else you're going to have to like migrate all of that, some user downtime and stuff. Of course, all of this we learned as we're growing. I don't know if you guys used this side. There was actually a time where we had to migrate and we had, I think it was like 10 minutes of downtime, but these are the lessons we learned. So resilience through self-correction. Yes, your LLMs can make mistakes. You have to like predict them. You have to expect them and try to catch it in some way. This is our way of doing like try catch for agents. Of course, there are probably better ways or like different ways. It depends on your use case, but it's something you should consider. Sandboxing, it's very important. I also think it helps us prevent like not prevent, it helps us, what's it called, like respect the user's privacy, because everything they do happens in the sandbox. Their files and all of that, we do not have any access to it. It's in the sandbox. When the conversation or the chat is deleted, all we have to do is kill the sandbox. And even like system wise, it's efficient because you don't want to have like multiple servers. If you're running it on your own server, you don't have to keep like millions of servers alive. So when the chat is inactive, you can just like pause the sandbox. When it's done, do all of that. So for both the user and the developer, I think it's a really smart and resource efficient solution. Lastly, sorry, what's that? Oh yeah, embrace Studio for local tools. Like try to reduce the amount of network calls you make. I feel like this is already obvious, but when anybody wants to, like, I type in a prompt, blah, 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 I need my answers fast and immediate. We're in the 21st century. Everybody wants data, like insights and all, at their fingertips. So you have to expect this, even if your stuff fails, you should be able to do it like really fast. So Studio helps us to just like pipe in and out. Everything is under the same process, so it's easier to accept. Thank you. Any questions, guys? I would I would look at the chats now. So let's see. Okay.
Okay, I can go ahead and ask the questions. There are a number of them. One is, how does the idea of self-correction apply to logical errors rather than code running errors? That's by Habib Chukweju.
Logical errors. First, allow me oh my god, allow me to ask like what exactly do you mean by logical errors? Because the way orchestrator works, because that's like our what's it called architecture, there's already a set path of how the what's it called workflow works, so like this happens and this happens. So Sorry.
Okay, I'm hoping he has a follow-up,
No, but
but
yes,
I'll
yes.
go ahead to ask another one. This is by Fumnaya Mowete. Do you have any insight into how Daytona was chosen as the sandboxing tech? They are asking because if I were naively trying to solve that problem, I would probably spin up a rootless Docker container or something and then go from there, or use Firecracker since it has to be fast.
Actually, I did experiment with Docker. Well, we had like our basic idea was okay, have like Docker containers, pre-install everything. But then it wasn't as efficient because sometimes it just leads to like extra bloat. Let's say we have like Docker containers with like 5 million stuff because we have to like expect, we want to give the same, what's it called? Service. Okay, let's say we spin up a Docker container. It has this and this and that, pandas, whatever stuff you want to use. It didn't like now we're speaking theoretically, but in practice, it wasn't exactly as fast. It was kind of slow. There was a lot of like time comparison in how fast it was to get like the results of the code we ran. For example, we actually started with E to B. Let me write it in the chat. E to B. It's actually a nice sandboxing tool, actually. That's what we started with. But we realized it's a bit slow. We are now optimizing for speed, actually. So everything's like, how fast can we go? I haven't tried Firecracker, actually. But Daytona is easy, and also it's already made to work with AI agents. So it's instinct, kind of. Uh, the next question, did
Okay.
the team build MCP servers? Sorry, can I quickly answer this?
Yeah,
First,
go ahead.
like I said, MCP servers already come standardized, but if you want to extend it, you can just like download, and you know how you download and build the source again yourself. We did that for our Postgres, by the way, because like I said, we only gave our Postgres MCP the ability to just like select. We didn't want like delete any other permissions or like any to be able to carry out any other query. So you can either use a custom one or use the standard ones. I think I would recommend custom ones because if you don't need a tool, you might as well just take it out. No need for unnecessary stuff.
Okay, so there's a follow-up to the self-correcting question. Two actually, one from Habib and one from Okbayemi. So Habib says he means in cases where the analysis might be wrong. For example, find me the top director, but the code somehow doesn't give code that correctly answers that. And then Okbayemi says the self-correcting loop is great, but LLMs have been known to sometimes modify tests so that their new flawed logic passes. The sandbox box helps, but he thinks there may be a gap there since the signal is no more error in quotes. So
Thank
he's
you.
asking, yeah,
Yeah. I think this is actually a very correct question, and this is actually why we do a lot of evaluation. I don't know if you guys have heard of spreadsheet bench. It's like a benchmark we use. So we try this like process with what's it called? Like these benchmarks. These are like files and CSV problems that an LLM is supposed to solve. So what we did before implementing this self-correcting loop is like we try it on this, how does it respond? Because while the stuff returns like error, benchmarks are real, it's like either a pass or fail. So I think I should say it has gone through rigorous testing. And also if it's bad, the users like always like resend the what's it called? Prompt. When you ask ChatGPT, like, okay, please do this. When you ask this, like, please do this. If it's not properly done, they send a second prompt. But from our experience, I think it works quite good. The only thing is like we've limited the number of times it runs and fails. Because what we notice is it's usually works well for up to 3 attempts before it starts to manipulate its passing. So we kind of set that limit at 3. Beyond then, it's like, okay, no, let's just pretend like this works. So you have to kind of find that like sweet spot. I didn't remember the second question.
okay. The second was a follow-up to that question from Okbayemi.
Okay.
Right. But I think you've addressed that. So there's another question from Mayowa. Great talk, Zainab. I'm curious, does your system interpret user inputs as queries or probes? If it's query based, how do you manage agent speculation to minimize unnecessary computation and improve response latency?
I think this is mostly about our system prompts because you always have to give system prompt like, okay, this is what you are. You have these capabilities and stuff. If you see this and this, so we do a lot of fine tuning. Like most of this stuff we use are custom. I think I've already recommended like prefer custom implementations because while the standards are good, you also need to know what your users want and build for that, right? So what we do is like we have a really specific system prompts. And because currently we have like extremely limited data sources. For example, what was my example? Like, okay, we want to check like which shoes are like what are best selling shoes, you know, and what if we have like so many data sources. So what we've noticed is like most of the times our users just use like maybe two or something. They say like online or an Excel sheet or something of like actual database. So we kind of query the two and just give both because it's better to give too much than too little. While it might improve the latency, but I think currently it's like the best choice, if you know what I mean. Hello.
Okay, thank you. So there's another question by Osinachi. If a particular tool didn't have an MCP server but had an API, did you just use the APIs like that, or did you just build MCP servers for those tools using the APIs or another means?
We actually prefer to build like an MCP server because, like I said, MCP servers help to standardize something. For example, let's say you want to build like an MCP server for recipes. I say it should be able to add a recipe to my database, blah, blah, blah. So there's a standard of the capabilities of that server. So when you make your request to the AI agent and the MCP server wants to work, it looks at those particular features or functions in the server rather than just like an API with so many endpoints. So a server itself helps you to standardize. The API is, oh, I said API, sorry. The agent is always able to do a quick lookup of, okay, I can do this and do this and do this before calling all of that. And like I said, we always want abstraction. We don't really want our agent itself to make API calls because they're a bit slower. It could be down or something like that. So we favor MCP servers and custom tools.
Okay, so that's all the questions we have for this session so far. We have just 1 minute left. So you can
Okay.
say anything extra. Yeah.
Okay, somebody said my email domain is misspelled. Actually, it's not. It's trydecide.co, not .com. Yes, it's correct. So feel free to send me an email, whatever. If like you have some problem with Decide, you need a walkthrough or something. I also function as like I say student ambassador, but everybody feel free to send an email. Yes. So oh my God, I'm sorry. Let me see. What's it called? Yeah, I see. It's try decide. Oopsie. Trydecide.co.
There's
Thank
one
you.
last minute one. Sorry, there's one last minute one that came in just now. Could we get another look at the current resilient architecture session? I don't think there's
Okay.
much time to talk through that, but maybe just show this slide.
Trydecide. Okay, let me quickly take a look. Do you mean this one?
Yes, I think that's what the person means.
So here I just talk about how like moving to MCP means we could use like pre-built standard connectors for Postgres and Metabase because that's what we started with, and also like customize based on whatever extra feature wanted to add because they understand our agents use case. It's like built exactly for AI agents, you know, so you don't have to really wrangle with like APIs, all of that. So here we add like our app as the process supervisor, calling the MCP servers for the subtask and all of that. Any other question?
No, no other question. We have to end it here.
Okay, thank you very much, everybody. This was nice. See you guys.
Thank you, Zainab. Bye. Bye, everyone.